Welcome SPHS Chemistry to another exciting e-learning video. I'm Mr. Hobbs, one of the chemistry teachers here. I am glad you're joining me today. This is a joint effort. All your chemistry teachers are working very hard to bring you this e-learning experience as best we can. Today we're going to start our next unit of solutions. Okay, now solutions. We've already talked about some of that, so this will be a little bit of a review. So this video, I always say they're going to be short. They don't always end up that way. But if we talk about matter, what we've been doing all year long is breaking up matter. And can it be separated? In other words, is it a pure substance or is it a mixture? Pure substances are either going to be an element, which we find on our periodic table, elements. Those are pure gold, pure silver, pure copper, pure oxygen, pure nitrogen. Elements are pure substance, only one set of properties. But compounds, when the elements combine chemically together, they form a new substance with new properties. One of the great mysteries in life, how can hydrogen that's a gas and oxygen that's a gas combine together to make liquid water? Well, it makes a new substance, water, with completely different characteristics. But you can have pure water, pure sugar, pure salt. So compounds are pure substances as well. And so if it's a pure substance, it's either an element or a compound. Elements are just the simplest thing. When they combine chemically together, they form a new substance with its own unique set of properties. And so as a result, you get a compound, a pure substance. But if it only combines physically, then we call it a mixture. Okay? And so there we have two different types of mixtures. You're very familiar with these terms. Homogeneous means the same throughout, and heterogeneous means not the same throughout. So if I go and I look at this solution right here, you can see that it's the same all the way throughout. There's not multi-phases. But if you think about chicken noodle soup, you got the noodles, you got the chicken, you got the little grease float on the top, you got all the different parts, okay? A solution is single-phased. The homogeneous, when it's heterogeneous, you have more than one phase. You can see different parts with different properties. Okay? So a mixture is either homogeneous or heterogeneous. Now, okay, there are three different types of mixtures. And it all depends upon the particle size. It's the Goldilocks thing, the small, medium, and large. You know, too small, too big, just right. Well, the smallest, when the solute particle, and again, the solute is the thing you're dissolving, the solvent, and we're going to talk about that in just one second, the solvent, what you're putting it into, but it's all based upon the size of the particles, okay? And so, as a result, we look then and see the smallest is a solution, then a medium, particles are the biggest. So what are some of the properties of those? Suspensions and colloids, okay? Suspensions, the particles are so large, they settle out due to gravity. That's gonna be your muddy water, okay? A colloid is at somewhere in between. And so it's sometimes hard to tell the difference between a colloid and a suspension, okay? But if we look at all the different types of, let's just come back, stay here. Okay, actually, I'm going to jump ahead and I'm going to get to our three types right here. If we have our three types of solutions, we have a solution, a colloid, and a suspension. The difference is the size of the particle, okay? So one of the things that we can use to measure that, let me see, where's my remote? Oh, it's over here, sorry. One of the ways that we can kind of tell whether or not it is what the size of the particle is. Actually, I don't want to do that. I want to do that. Okay. We can tell the size of the particle by, first off, solutions are always clear. Not necessarily colorless, but they're going to be clear. But solution particles are so tiny that when you put it through a piece of filter paper, okay, it will filter right through. Notice it's staying yellow. Okay, and so as it filters, the solute particles are small enough to fit in the little tiny pores of the paper, and we end up still getting this yellow solid pouring, this yellow solution pouring through. So a solution cannot be filtered. The particles are too small. Now, if I take that same, this is potassium chromate, and I add a little bit of silver nitrate to it, okay? let me turn it so you can kind of see this way. Okay, I add a little bit of silver nitrate to it. You can see the red beginning to form in it. Okay, those are big chunks. Okay, whenever it goes cloudy like that, that's an indication that there's a precipitate, that you have an insoluble solid. Now we have a suspension. We have big particles that are just floating around in there, but eventually all of that red will settle out. Now notice I had a whole lot of the potassium chromate and I only put a little bit of silver nitrate in there, so the potassium chromate, the yellow, is the excess. So I'm going to filter this one now. If you guys remember, cut it, fold it in half again. Okay, you now have 4 pieces of paper, grab 3 of them and spin it. Okay, but it wants to pop out, so here's a little trick. Spray it with some water, and water is very sticky, so it will stick in there on the sides like that. Now, if I go to filter this, okay, we're not trying to do anything quantitative, so a little bit of water won't hurt. If I go to filter this, note only the yellow is coming through. The excess potassium chromate, the part of the solution that didn't react, is still coming through the filter paper, but no red is coming through because the red particles are too big. It's a suspension. Okay, so when we look then back, back here, okay, the particle size solutions are so small that they can't be filtered. Suspensions are big enough they can be filtered. Now, so how do we differentiate a colloid? If we get a super fine filter, and the most natural, super smallest hole filter is a cell membrane, a semi-permeable membrane. Okay, so those holes are very tiny. Okay, and so as a result, a solution can still go through a cell membrane, so the Na plus and Cl minus in your blood can get in and out of the cells. But a colloid particles, they can't get through that. They can't be filtered. Okay, they'll go through a normal piece of filter paper, but because the filter paper hole is too big. But semi-permeable membrane, they can't get through. So that's just another way to be able to tell the difference. But sometimes colloids kind of look like a solution. So we do what's called the Tyndall effect. Okay, the Tyndall effect is when you shine a light through the solution or the colloid, the light gets scattered. Now think about this. If you're driving on a country road where it's dark, normally you can see the headlights. They scatter because there's a whole bunch of dust particles separated, suspended in the air. So we have a suspension so that your headlight gets scattered and you can see the beam. Or if you're at the beach and you have a flashlight and you shine it up in the sky, you can see the beam of light going up because the dust in the air is scattering it. However, on a rainy night, the rain is washing all that dust out of the air, and then we just have a solution of air, and as a result, you don't see the beam. Sometimes I've had to turn my lights on and off just to see, are the lights really on or not, because there's no dust in the air, nothing causing it to scatter. So colloids and suspensions will scatter the light, whereas a solution will not. So that's this is also why you have to use your high beams, your low beams on a foggy day, because if you use your high beams, then as a result, it scatters the light in front of you and you get a big sheet and you can't see anything. So driving lesson, in a foggy day, you want to use your low beams because you don't want the Tyndall effect to affect you. You don't want it to cause you an accident, so use your low beams. So you may or may not have known it, but it's science. It's the Tyndall effect. Okay? So when we're shining, you probably cannot see this, but there's no beam. This is a red laser beam being shot through. You can't see anything here, and there's a little red line being right here. So since we can see it here, okay, which glass contains a solution? Well, it's the one you can't see is the solution. This is the Tyndall effect. Because we can see the beam, okay, it's there. All right? So I'm trying to see if this, it's going to probably take a while for this to settle out. But you can begin to see on here that all of the red is being filtered out. Okay, the yellow solution is passing through the filter. So these are just some of the different characteristics of solutions, colloids, and suspensions. All right, So now let's just talk specifically about solutions, because that's what we deal with in chemistry. Okay, so we know that the solute, again, is the thing being dissolved. So if I have just some water, and I take some sugar, and I put this sugar, I take the sugar and I put it into the water, okay? The sugar is the solute, the thing being dissolved. The water is the solvent. So I mix this together, and if it's soluble, it's going to disappear because the particles that were all clumped together, all the sugar molecules that were stuck together in the crystal, are breaking up one by one, and so they're getting so small now in individual molecules we can't see, so the water is breaking them apart and making them go into solution, okay? Same thing if I took salt, and it's no different. I take salt and I put this into the water, okay? And I dissolve and stir this up, okay? The salt is going to dissolve. Now the difference is salt's ionic, sugar is covalent. This is going to dissolve as ions, that's going to dissolve as molecules, but we'll talk about that later in this unit. Okay? So the solute is the substance being dissolved, the solvent is the thing you're dissolving. Okay? We already talked about this. So solution is homogeneous, very tiny particles. They're going to be atoms, molecules, or ions. Usually it's molecules or ions. Covalent compounds dissolve as molecules, ionic compounds dissolve as ions. Okay? It's not too hard to keep track of. Okay? And we already talked about this on that table right there. So, what types of solutions do we have? Well, you can have anything in anything. A gas in a gas, everybody take a big breath. Ooh, you just breathed in a mixture of oxygen and nitrogen and argon and carbon dioxide and some water vapor. A gas in a liquid. Ooh, that reminds me. Ooh, I need a drink. I need to get fired up. Okay, we're hearing that pop. That's the gas coming out of the solution. Okay, it's bubbling in here, but that's what makes it so good. So, the fizz and pop is carbon dioxide in water. Any mixture of two liquids, okay, that's common. A liquid and a solid. Now you don't hear about this very often, and they don't do this anymore, but my mouth is full of mercury amalgam, mercury and silver amalgam fillings, and I get the big silver fillings in my mouth. Okay, that's what they used to use in the dentist. Now it's safe because the silver encapsulates the mercury. The mercury can't escape; they're stuck. But it's a liquid mercury trapped in the solid silver. And then a solid and a liquid is by far the most common, and solid in a solid is what we call an alloy. Okay, an alloy. Many of y'all may have heard of an alloy. Alloys can be anything. 14 karat gold is an alloy because 24 karat pure gold is too soft. It won't keep the shape of a ring or any jewelry. It would bend and be very soft. You always see in the movies, they bite into it, or at the Olympics, they bite into the gold because if it's pure gold, it's going to be soft. It's going to make a tooth imprint. Okay? So there's all kinds of alloys, which is a metal in a metal. Now that's a physical mix. They are not chemically bonded. They're only physically mixed together. So it's a mixture, not a compound. Okay? And then aqueous solutions, those are the ones that are dissolved in water. Those are the ones that we use in chemistry all the time. And so as a result, this is the one that you really, we're going to focus on, aqueous solutions in this unit. Okay? So, you can stop now the video and go ahead and do your comprehension check. Okay? And that concludes part 1 of our solutions chapter.